Awesome. Thanks for joining everybody once again. I'm Travis Durick, and as always, we have Professor P, Peter West here, and today we're going to talk about Wi-Fi mesh.
I'm pretty excited about this, Travis, because I think people get Wi-Fi roaming confused with Wi-Fi mesh, and
Oh yeah.
I thought it'd be fun to like talk about meshing, but also preface this with a little bit of education on the difference between roaming and meshing. Because I think people think, oh, I want to connect multiple Wi-Fi access points together, therefore it's meshing. But there's a difference between wired connectivity where you can roam between APs and meshing where we're wirelessly extending your network without wires. I'm pretty excited today. We get to talk about some technologies that go hand in hand, and then we're going to do a little um, guide. I've got three Wi-Fi AX APs sitting here in the car, and so as long as my power doesn't shut off on me, I'm going to demonstrate that to you guys. And so I think overall we're gonna have a really fun hour.
I think that's a really good point too. Yeah, I hear that term mesh get used, like you said, for roaming, and yeah, that's a different thing, but they definitely have some interplay here, and that's a good one to dig into.
Yeah. And so I'm actually going to start with that a little bit. We're going to talk about what is Wi-Fi meshing versus Wi-Fi roaming. And Peplink supports both. And that's a kind of a neat thing about this. But Wi-Fi meshing is the ability to extend the coverage range of your Wi-Fi network wirelessly. And I know that's a lot of the word Wi-Fi in the description, but it's important. So basically, we have your router or an AP, and you don't have the ability to run an Ethernet cable from the router to another Wi-Fi AP to extend the coverage area. And so the idea is with meshing, I can put up an AP in my bedroom and have it wirelessly connect to the AP in my IT closet and then extend the coverage range so that as I move around my home, I can roam. So I can connect from one AP to the other AP seamlessly. And so roaming is the ability to connect between one AP and another AP seamlessly as you move around a building or a space. And so often people think of, oh, I need to be able to mesh my network together, but you can roam wired or wireless. So if I have like right now, I have three APs plugged in for my demo today. They're all connected via Ethernet because I'm going to program them. So I could set up roaming between these three APs that allows me to hop from AP to AP to AP as I move around my building. Now, obviously, I'm in a car. I'm not going to move around the building here, but if I were to have these in a building, I could roam with those seamlessly using Wi-Fi roaming built into the Peplink routers. Then I could unplug the Ethernet wires from these APs and mesh them together wirelessly and then still be able to roam as an additional feature of the APs. And so we're going to talk about meshing today, which is the ability to extend the coverage area of your network wirelessly. So no wires needed. And so a lot of times you've got you can't run physical wires, or maybe it's too costly, or you need a temporary location where you just want to extend the Wi-Fi capabilities of your network.
Yeah, like normally in an enterprise network, you're going to have multiple Wi-Fi access points, and they're all going to have an Ethernet cable running to them back to some central point. So they're all broadcasting that same network. And like you said, you can roam between them, but each one of those APs is hardwired in a normal scenario. And so that's not meshing, right? Like you said, that's roaming. With meshing,
Correct.
you have a spot where it's hard to get that Ethernet cable to that access point. And so meshing lets you put that thing where you want it to add coverage there, but you don't have to have that wire to it. And there's some trade-offs and things that we'll discuss there too, but it's a great tool to give you that flexibility to fill in coverage when it's just not possible to get a wire to that one access point.
Correct. And actually, part of this discussion is going to be some limitations to meshing that I think aren't commonly shared. Like, oh, mesh, it's easy, it's simple, but there are limitations related to performance and things like that. And so I will caveat this where if available, you should always run wires between your APs. You're going to have much more stable wireless network where you can roam seamlessly throughout the infrastructure. But that's not always the case, and that's where meshing comes into play. And so we'll talk about that and how we can use in control to zero touch configure Wi-Fi meshing. And then I have a live demo. We'll actually set that up and actually unplug the Ethernet wires and show it switch from a wired AP setup to a meshed AP setup.
Yeah, and meshing is a super useful and powerful technology, but like you said, it's not your first primary tool. If you're trying to add more Wi-Fi coverage, you should plug it into an Ethernet backhaul if you can. But if not, then meshing is the tool for you.
Exactly. And so in a traditional home or small office network, you're going to try to put an access point or your router centrally located in your building or space. So that way you can provide this wireless network connection. And you got to think like if you have a router and then you're going to have wireless coverage, it's going to span around that router. So you have your router and then you have the coverage area of that router. And so a lot of times you might put your router next to a wall or a service area where the cable internet or the fiber internet's coming into your space, and that actually has to be in the one of the walls of your space. And so if you go to the other end of your space, you might not have good coverage, whereas if you could put your router in the center of your space, it might actually provide enough coverage. And so the idea is that with router placement being unpredictable, sometimes you might not have perfect coverage throughout your space. And so meshing allows you to basically take another wireless access point, like an AP1AX that I have here with me in my car lab, and then place it somewhere else in your space to extend that coverage. And so it grabs greater flexibility. You don't have to worry about running physical wires, and then they're going to talk to each other and extend that Wi-Fi network for seamless roaming as you move around your space.
I think another term that we hear a lot that's going to maybe confuse some people is just a repeater or an extender. That there's some kind of common similar terms that are maybe almost the same thing, but they're still slightly different than mesh too. So mesh is like a better version of a repeater, if that makes sense. But we'll get into more details as well here.
Yeah, and actually, I don't really have a slide on repeaters, but and since we're
Mhm.
talking about that and we're talking about comparisons, back in the, I want to say the early 2000s, late 90s, you just get those little Netgear repeaters, and
Yep.
basically you would program it to talk to your Wi-Fi network, and then it would rebroadcast a network. That was sort of a makeshift version of like WDS, right? But it's
Yep.
actually a Wi-Fi client and then access point. And so it's not the same thing as a mesh. A mesh is designed to basically streamline the WDS process, making a layer two connection throughout your network for that backhaul. Whereas a repeater is actually acting as a client, connecting and then rebroadcasting. And so it makes it a non-seamless network. You're not going to be able to have Wi-Fi roaming. You can't go from one to the other seamlessly. It's going to have a small disconnect as you go from one repeater to another repeater, because they're actually clients with a broadcast.
Yep. Yep. Mesh is just a
Um,
more sophisticated repeater, and you can have more advanced layouts where maybe one mesh node connects to another mesh node, which connects to a wired node, where repeaters, you're just not going to be able to automatically support those kinds of layouts. And so, yeah, mesh is the basically the enterprise version of a repeater, I would say.
Setting up wireless network meshing is very easy with Peplink. There's two ways to do it. One, well, like most Peplink products, we have our UI, which is like the balance UI, and then we have our cloud in control. And so you can set these up on the UI, or you can set up meshing in control with zero touch. I'm going to live demonstrate zero touch, and I will use these slides to demonstrate the UI. If you log into your wireless APs, you simply go into the meshing of WDS mesh tag area, the AP, and then you can go into wireless meshing, which is right below WDS. And then you can create a new mesh network. And you would plug all your APs in, log into them, go to the AP tab, and then go to mesh configuration. And then you'd be able to set up your meshing. If you're running 8.4.2 or earlier, you're going to have 2.4 and 5 gigahertz. If you're running 8.4.3 or 0.4, you now have the ability to do 2.4 and 5 gigahertz. So you're gonna have an additional radial option here called both, and I'll show you that when I do mine. You basically have to do two things though, and this is a common mistake. You have to create the wireless mesh, then you have to assign the wireless mesh to a profile. So we have AP settings, profile settings, and then you're going to have to assign the wireless mesh to the profile. And if you don't do that, you're not going to be able to get the wireless mesh settings. And so you want to make sure we do that. If you're not using in control, you create the wireless mesh, then you assign the mesh to the profile under settings. After you do that, you're going to get this. If you're running 8.4 firmware, you're going to get this really nice new mesh link information page. And I created this when I have a YouTube video also where I talk about this, but basically we're going to have this mesh information page that now shows up, which is really nice. It gives you all of the signal strengths, the type of connection that's happening. It gives you the link type, so you know which ones are Ethernet, which ones are Wi-Fi. And it's going to give you a lot more information about your signals, as well as it's going to give you that 2.4 and 5 gigahertz with the throughput and signal strength. So you can really see a lot more of what's going on. And once again, I'm going to demonstrate this in real time with my lab. This is new with 8.4. Sorry, there's so many firmwares. 3.8.4 Wi-Fi firmware that you're going to be able to get this new UI that gives you a lot more information about meshing. So it's a great feature that they've added. Because sort of previously it was just a status, and you really didn't know everything out there. It was just that top bar right there, that mesh status. It basically said, hey, here's your mesh, and you're connected. Now you get this mesh link information tab. So then you can do it in control, and I'm going to show you that in real time. So I'm going to exit this. And I have my Peplink University. If you have not already seen this, this is sort of my play lab. So I'm actually using my SpeedFusion backpack. So this is my BR2 Pro, and I've got my my internet connections here. Then I have 3 APs hardwired to my backpack, and then I have 12-volt power supplies to them. This way I can unplug them from Ethernet and set them up. Right now, I have no Wi-Fi's provisioned on these. These are just blank devices. They have no Wi-Fi program. So I'm going to set up a Wi-Fi SSID and then program meshing for these devices. Now, I could use my BR2 as because it's a Wi-Fi 6 device, I could use my BR2 as the base, as like kind of like the central point mesh. But because I'm on my Wi-Fi talking to you, I'm going to have this completely isolated. Okay, so the first thing I'm gonna do is I'm gonna program my SSID that I want to broadcast. I'm gonna go to my Wi-Fi group-wide SSID settings. I'm gonna click Add New SSID, and I'm gonna name this Mesh Demo. Then I can say Device Selection, and I'm gonna apply this to some devices with the tag Mesh. So when I added these serial numbers, the APs to in control, I tagged them with the word mesh, saying, hey, I want to make sure these are part of this. If you have a whole bunch of devices, you could have mesh 1, mesh 2, mesh 3, etc. if you wanted to. And then I'm going to set my security policy. So I can say WPA2, WPA3, and give it a little password. I'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 for this demo. And you see this right here, fast transition. This is what we talk about roaming. So if you have hardwired devices, which these are, and I turn on fast transition, that allows me to go from AP to AP very smoothly without dropping connections. So the APs are going to transition, but there's one more thing that we're going to do to make that transition even smoother, which I'm going to show you today. Then we have all of our other SSID options. We have a whole training.peplink.com where you can learn about these. But for right now, we're just creating the SSID. So I'm gonna hit Save Changes. Now, in order for wireless roaming to be efficient, we need to give it a signal threshold. In other words, we're gonna say, hey, at what signal do I want to allow these to roam efficiently? And so the next thing I'm gonna do is I'm gonna go to my Wi-Fi AP group-wide radio settings. And I'm going to filter by mesh, which I can do right here. And then I'm going to select all of my APs. And you can see I've got 3 APs, but 6 items here. So you can see there's my 2.4 and 5 gigahertz on each of those APs. So first, I'm setting my output power to low. Once again, I'm in a car, don't need them broadcasting. The next thing I'm going to do is I'm going to set my minimum client signal strength. This is critical for seamless roaming. This actually has nothing to do with meshing, but more importantly with roaming. So if I set my signal strength to -71, which is recommended for like HD video quality and Teams and things like that, then that means that as I move from AP to AP, as soon as I hit -71 dBm, it's my laptop or my device is going to start looking for the next AP. So instead of holding on until I have really bad signal strength, then moving over, and it'll still move over seamlessly, but I'm going to move over once that signal is poor. I could force it to move over to the new AP while the signal's still good. This means that my Teams and my Zoom calls, if you're doing a consistent ping, all those things are going to affect move over very efficiently and without high latency as you step away from one AP and get closer to another AP. So I like to set it up as -71 and then set up my placement of my APs so that way I've got a constant -71 signal or better throughout my facility. So I'm going to go and apply changes to that. So now my Wi-Fi is set up. I've got my Wi-Fi mesh signal set up. I've got fast transition, my roaming set up, and I've set my signal client strength. So I know, hey, as I move from AP to AP, it's going to be very clean and seamless. Now I can set up meshing. So I'm going to scroll all the way down to this radio settings, and you see this wireless mesh. I can create multiple mesh IDs here. So if I have a large organization with a bunch of different sites, I can create different meshing topologies, or I can just have one meshing topology and just literally plug APs in wherever I go, and it's going to be seamless meshing across my entire facility or facilities. So I'm going to create a Wi-Fi mesh ID. So I'm going to hit add. I'm going to call this mesh. I'm going to do frequency both so you can see what that looks like. And you can see right here that this requires 8.4 firmware and 3.93 or above. Then I'm going to give it a pre-shared key. I'm going to do the same 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I don't recommend that, obviously, if you're setting your own network, but for POC, this is fine. Hit OK. Now, remember I talked about with the manual setup, we have to create the mesh, then we have to assign the mesh to devices. So right here, device selection, all devices, device managed. So I could say disabled or device managed. Then I can go in here and add, you see that plus right there, hit plus, and I can say devices with any of the following tags or with none of the following tags. So I can with any of the following tags, mesh, and then I can assign it my mesh profile above. This says my 3 devices that I've assigned for meshing, assign this mesh profile. So I hit save changes. And now I've set up my wireless SSID, I've set up roaming, I've set up the mesh ID, and I've pushed it to those 3 devices. So if I go back to my dashboard, I can see there's my 3 devices. They've been online for a little while here. And you can see a few seconds ago, they received their configuration change. You can see that right there. So if I go into this device right here, 6825, you can see right now I'm connected. There's my IP address. I'm Ethernet wired. I can go to settings, remote web admin. The AP tab. Oh, hold on, let me go back real fast. There you can see my mesh demo Wi-Fi, 2.4 and 5 gigahertz. So it's set up right there. So that's the Wi-Fi that I pushed out. Then I can go to the AP tab. And then if I go to AP Wi-Fi wireless mesh right there, there's my mesh profile automatically getting pushed right from in control. And you can see right there, it says managed and in control. So if I'm not using in control, I could add the profile manually. But right there, it says in control management enabled. and you can see my mesh profile, frequency both. Then if I go to my mesh status, it's going to show there. You can see there's my 3 APs, and they're all linked via Ethernet. You see that? So I can see my 3 APs that I have plugged into my vehicle here, and they're all connected via Ethernet. They're all at gigabit. And so you can see that those are there. So now what I'm going to do is I'm going to unplug the Ethernet from these devices. So here's my device. So I'm going to unplug the Ethernet from this one. And I'm going to unplug the Ethernet from this one. And I'm going to keep the Ethernet on the hub device, my device that's actually physically plugged into the router. That's going to make sure that's like sort of my hub and spoke, right? So I've got my main AP plugged into my router, and now I'm wirelessly bridging these two remote APs. And so in a few minutes or a few seconds, hopefully, it doesn't take too long, those will then change to wireless, and I can pull those up. I can see those in control, so I can go back to in control, and I can pull up these two devices. You can see they went offline, and in a few seconds they should come back online with their mesh settings. So there you go, no cable detected, but see how it's online, and in a few seconds it's going to say wireless mesh there. There it is. Oh, look at that, connected via Wi-Fi mesh. You see that? And this one should say the same thing in a few seconds. And if I go to this one, you can see both of them are connected right there. You see that 2.4 and 5 gigahertz, 2.4 and 5 gigahertz. And then there's my kind of APs and my mesh connection there between them all. You see that? So they're all talking to each other in a mesh network. I can see my signal strength. I can see my capabilities, my throughput, my devices. And this right here, this chart is new with the 3.9.4 firmware. And I think I said 3.8.4. I apologize. Confused that with the 8.4 and 8.5 firmware. It's 3.9.44 AP firmware. And you can see that now I've got my wireless mesh set up. So almost effortlessly, I was able to create this Wi-Fi mesh using 2.4 and 5 gigahertz, creating a completely scalable network with zero touch configuration using in control. The key here is I plugged in the APs first, brought them online, made sure they're running 3.9.4 firmware using in control. Then I provisioned the Wi-Fi SSID, and then I provisioned the mesh profile, and then I pushed the mesh profile to those 3 devices. What I did not show you, which I'll show you real fast because I forgot, is when I added these devices to in control, you can click the edit tag here. I selected the 3 devices, these 3 APs, went to tag, and I created a mesh tag, and then I assigned that mesh tag to those 3 devices. So when I added these devices to in control for the first time, I assigned the mesh tag, and that's how I manage that. I did that before the webinar. I apologize. I should have done that when I started, but then that's how I got the mesh tag right there. And that's how we can then zero touch and provision those settings. And you can see that that's all online.
I think this here, if you go back to that diagram on the status, yeah. So this is an important, I think it's hard to pick out here, but this illustrates something really important about mesh. And we've talked about repeaters and extenders before, but mesh can go multiple directions at the same time. And so what mesh is doing is it's evaluating the different paths. So you can see we've got this triangle here. So this 2850 is the master. That's the head end with the internet connection. Or is it 6825?
Yeah, 6825 is the master. And then
okay.
and these are the 2 remote ones.
And so what you can see if you look at each one of these lines here, there's different connection paths. And it looks like we lost the one. It looks like, oh no, there it is. Okay, so there's 2
there's 3.
There's 2 paths for each. So you've got 6825 to 2A50 on 2.4. You've got that same AP to AP on 5 gigahertz. Then you've got 6825 to 4D75 on both frequencies, but then you've got this other one, this 2A50 to 4D75. So there's a path between those two remote wireless links too. And so what it's doing is it's evaluating each path. So it has two different ways that it can get back to that internet connection. It can go directly to it, and in this case, it's choosing that. You can see the transmit rate on letter B there. It's not transmitting anything back and forth there. It's not choosing that path, but it could. But
Yeah,
again,
if this moved too far away and this wasn't good, it could actually relay through 4D75, then get to 6825.
exactly. And so it's dynamically evaluating those different options and giving you different ways to get that traffic back and forth. And it's actually changing that real time there too. So that's an enhancement of mesh over something like a repeater. A repeater is going to be a static thing. Like you said, it's not going to roam completely seamlessly. And it's not going to make those transitions and dynamically update like that either. So mesh is just a much more sophisticated way, which is going to give you better results in the end when you have change. RF environments change dynamically all day, every day. And so if a forklift moves in between this one and that path may change. It may find a better path. What you see in the real world with your eyeballs or on paper with a building layout is not what the RF paths look like, right? Those change a lot and dynamically. And so mesh just finds more ways to get that traffic back there efficiently and dynamically.
Exactly. And I do have two really good questions, so I'm going to adapt them or address them real fast. Somebody asked if we can, if meshing is brand specific, this is definitely brand specific. You're not going to be able to mesh a Peplink AP with an Aruba AP. You're going to mesh with Peplink to Peplink.
Correct. Another question I see, does
Um,
mesh functionality disable the use for band to mesh or user access? And the answer is no. You can use one frequency for both. You can choose either way, right? You can dedicate a frequency for mesh and not let users on it, or you can use them for both purposes. And I would say there's some nuance to that too, but
yeah, so you're gonna have if you broadcast and connect on the same frequency, you are sharing the power of that radio, and so you are going to have some degradation of performance. So you do want to pay attention to the fact that the more mesh hops you have, the lower the performance. Don't expect gigabit. Now, what's really nice, if you see that we're negotiating at 2.1 gigabits per second on the 2.4 and 2.1 on the Wi-Fi 5 gigahertz. So that 5 gigahertz frequency is actually broadcast or able to backhaul at much higher performance. So if I lose performance going from 5 gigahertz to 5 gigahertz, I'm still over a gigabit per second. Even if I went a third hop, I'd still be over a gigabit per second. Whereas the 2.4 gigahertz, you can see is only connecting at, almost 600 megabits per second. And so, but you will lose performance when every additional hop. And then if you're sharing a radio, if I'm connecting mesh on 2.4 and 5, and then I'm broadcasting an SSID on 2.4 and 5, then that is sharing the power of that radio, which will lower the throughput. So even though I'm negotiating at 2.4 gigabits per second, I would not be able to achieve 2.4 gigabits on the client side due to the fact that some of that radio is being used for the meshing as a client itself. And so there are some nuances to that. And because it's so variable, it's not fun to say, but sometimes they say, you should estimate around 50% degradation per hop. That's kind of a good line of sight. I've seen better results and worse results depending on where your environment. But it is important to know that you want to. So I'm driving up to Wisconsin right now, and we're doing a mesh network. I'm using 5 gigahertz as my backhaul. So I'm only doing 5 gigahertz for the mesh. And then I'm broadcasting at 2.4 gigahertz. That way I'm dedicating the 2.4 gigahertz channel to Wi-Fi. And then I'm using the really high speed 2.5 gigabits per second, 5 gigahertz frequency to provide the backhaul throughput. That way I can mesh further away and still provide, 600 megabits per second of 2.4 gigahertz to the clients. And there's a whole bunch of different use cases and reasons for different scenarios, but this I've got to cover a huge outdoor area, and 2.4 gigahertz goes further, and that's just the decision that we made. But the point though is that you want to take those things into consideration when you're designing a network.
Yeah, the Wi-Fi radio can only transmit or receive at any split second, right? So it can talk or it can listen, just like, when you're having a conversation, you talk and listen, right? You have to kind of like take turns in that exchange. But so the 2.4 gigahertz radio can talk, listen. But then, like Peter said, he's using the 5 gigahertz radio to mesh, so the clients can talk and they can immediately relay that back. So it can hear that, transmit that on the other frequency because it's using two radios then. And so that takes some of those bottlenecks out of the equation on the mesh side. But there's, again, a lot of details to all of this. There's people that have
Yeah,
dedicated their entire careers to setting up mesh networks and Wi-Fi networks. And so we could spend a whole week on this topic if we really wanted to get into the weeds on this and designing for this scenario or that scenario. And that's why this is a tool of, lower preference compared to just hardwiring your access points. You don't have to really talk about any of this stuff if you just plug them all in. But again,
exactly.
it's not always possible.
Tom asked a really good question too. He said, can we use the LAN WAN port on the AP? 100%. So once I've disconnected that AP from my router, I could now plug a laptop or a switch into that one of those remote APs and extend an infrastructure wirelessly. So you could plug in cameras, phones, etc., and then basically wired handoff on that mesh network. So if I plugged in a switch to 4D75 right here, I could then have devices, Ethernet devices connected that are then connected via this wireless mesh that has redundant paths back to 6825. And so that is some benefit there to meshing that you can definitely do. How will this work with existing spanning tree infrastructure?
I'm guessing that the spanning tree bridge ID was the same between the switches and the access points or something along those lines. I get what Matthew's getting at
Yeah,
there.
yeah, I see what
That's
you're
gonna be a
saying.
very vendor specific and like kind of like hard to predict exactly vendor to vendor on that. I don't know,
You de
frankly.
you definitely want to make sure you're not looping switches. So if you're meshing and then you have two switches and those switches are connected and then you're meshing, you got to make sure spanning tree is set up properly, so that you don't create a loop. But a proper spanning tree deployment should fix that for you. So it's just making sure you have the priority ID, or the priority spanning tree priority on the switches at a different rate. So the closer you are to the router, the lower the higher, I guess, the lower the priority number would be, like 4,000 instead of 16,000. So you should be like 4096 when it's really close to your router, and then the further you're away, that priority should be a higher number. Kind of like getting that away from your network, like I'm farther away. No, we don't support 100. Oh, is this a 160? No, I think we support 20, 40, and 80 megahertz. So we don't support 160 yet. Right. That would be Wi-Fi 7 if I'm not mistaken.
Gosh,
I'd have to ask Gidris. We support 20, 40, and 80 though. We don't support 160 yet.
80 for
So
sure. But yeah, I think you're right.
yeah. Yes. Someone says we keep the hops to a minimum. You should definitely keep the hops to a minimum. If you can have wired devices and then extend out at minimal hops, you're going to have the best performance. Hit those one or two areas that are further away. But if you can reduce the hops, it's going to be better.
With these three access points, if you look at like the base that has the internet connection, that's like 100%. The first hop is going to be 50%. The next hop is going to be another minus 50%. And so that's going to be 25% is your best case scenario that second hop would be 25% of the throughput of a normal hardwired AP. So again, that's your best case. If your mesh links are perfect and your client to AP path is perfect, a 2-hop node is going to at best have 25% of the throughput of a wired AP. So hops are bad for speed. Now, that may not matter if you've got a 1 megabit device that needs to connect, or a bunch of low throughput devices. That may be no big deal, but if you're trying to, max out the throughput of a traditional access point, mesh is going to take that speed way down really fast. And so it just
But
depends on what you're trying to do.
and that's also why 5 gigahertz matters, and 6 gigahertz, and six, in the future here, 6 gigahertz matters because you're going to be able to get that higher base rate. So as you go hop further down, you know, taking 50% of 2.1 gigabit, or 2.4, you see, that's 1,200 megabits per second link speed. So then my next one is 600 megabits per second. So 3 hops is 600 megabits per second at, which is the same as 1 hop on a 2.4 gigahertz frequency. And so I can go 3 hops on 5 gigahertz and equal or exceed a single hop of 2.4 gigahertz. And so if I were to take the 2.4 gigahertz and span that out 1 hop, my next connections would be at 300 megabits per second. And so you just got to pay attention to the fact that every additional hop is going to be affected by link speed. And so that's why, especially someone asked about 160 megahertz frequency, or if the more frequency we can get, the more throughput we're going to be able to achieve, the better it's going to be able to mesh out. And then that also goes into, like I said, if when Wi-Fi 7 comes out and things like that, we have the 6 gigahertz channel. We'll even be able to have even more capacity than we have now. But 5 gigahertz at 2.4 gigabits per second, pretty good, especially when you're talking about a mesh network and backhaul to gigabit Ethernet ports. Okay. So we did have some standard question answers, but you guys answered most of them. But how many hops can this be supported? It's not advised to have more than 2 to 3 hops, and we just did the math to show you that. We've done some testing, validation, and you can get more than that, but the performance starts to drop. So like Travis said, you could have IoT devices that only need a little bit of throughput that you could hop more, but you're gonna sacrifice capacity dramatically as you get to those 4th and 5th hops. Are there any limitations to the hub device? If the hub device has a direct gateway, it depends on which radio frequencies the hub can support. Once again, making sure that 5 gigahertz or the Wi-Fi 6 versus an AXAP versus an ACAP, right? So if you're running like a 20x with an ACAP and you're trying to mesh Wi-Fi 6 devices, the AXAPs, you're not going to get the same frequencies and capacity. So you want to mesh like devices. So you want to make sure you have a Wi-Fi 6 hub with Wi-Fi 6 spokes. So you want to, like if you have a BR2 Pro or a BR1 Pro, those are Wi-Fi 6. You're going to be able to mesh those with other Wi-Fi, the APAXs or Wi-Fi 6 devices. The other note that I thought was pretty cool that engineering put together was talking about the MIMO. So the AXAP is at 4x4 MIMO, but the BR1, BR2, and the AX Lite are 2x2 MIMO. So you have more, the AXAP is going to be able to mesh at higher capacity than a 2x2 MIMO device. Once again, that goes back to what Travis was talking about when we were talking about sending and receiving, and the ability to do those simultaneous communications. The AXAP is going to handle that way better than a 2x2 MIMO device.
Yeah, I think it's kind of like, we start at some number and then each hop is going to take you down lower and lower. And so if your gateway, that base access point only has 2x2, your base number is cut in half already. So again, there's just a lot of interplay, and it's just kind of a waterfall or a domino effect. And so the stronger the base, the better the endpoint connection will be on the other side, and so on down the chain.
Exactly. Are there any performance? I think we already talked about that enough. So they put it in writing for us, but the idea is we've already talked about dramatically. Are there any rebroadcast limitations? And we talked about that as well. But just paying attention to the fact that if you're using 5 gigahertz for mesh and then you're using 5 gigahertz for rebroadcast, you're cutting that radio capability in half. Um, yeah, and so now we can answer questions. It's a rather simple topic, or short, straightforward topic. Mesh. Let's see. Yeah, there's a lot of mesh solutions. Somebody kind of had a mesh question there. Um, are VLANs trunked over the mesh? This is layer 2, so VLANs should be it should be treated like a layer 2 handoff. So I think I should test that. Travis, I don't know if you know, but the VLAN should pass through a
I'm
mesh,
almost
right?
positive the answer is yes to that. You can
Yeah,
switch in and trunk through that because, similarly, you can have multiple SSIDs mapped to different VLANs as well. So I'm
that's it.
like
Yeah.
95% sure that's a yes, but I have not
I'll have to hook up a switch and test
that
it.
thoroughly.
I will Tom, I will test that for you, and that's a great question. But I'm 95% because you could do SSIDs with tagging, and mesh works over the SSID, so those VLANs should pass through just fine. But I have not actually tested that in my lab environment. Most of what I do is Ethernet based when it comes and then roaming. So most of my enterprise deployments are all going to be hardwired APs. But I will check that. But I know you can set up SSIDs with VLAN tagging, and those work over mesh. So the answer should be yes. Um, but good question.
See, Haruki mentioned that there was an old deployment. Haruki and I worked together, I think, 15 years ago on a Wi-Fi mesh network. And so that was 802.11g. It was a single radio, 2.4 gigahertz, and we had, I think, 350 mesh nodes over a city doing Wi-Fi coverage. And so it was like 1 to 2 megabit service for internet service. But yeah, it's the technology's come a long ways, and so this is a much faster, much more modern version of that. But it was the same concept that many years ago, but just way better hardware capabilities now today.
I kind of mentioned this already, JC, but Wi-Fi, you can mesh Wi-Fi 6 and Wi-Fi 5, but it's recommended you mesh like devices. So mesh Wi-Fi 5 with 5, mesh Wi-Fi 6 with 6, because you're going to be degraded in performance. So you're not going to get the Wi-Fi 6 performance meshing to a Wi-Fi 5. So like if you have the AP1 enterprise, mesh that with other AP1 enterprises. Try not to mesh that with AX, because you're going to basically lose the performance of it.
There's there's so many details that are going to play out in terms of like what you use as the base, what you use as the nodes, and there's just so many variables and differences, but they're all compatible. It's just going to
Yeah,
have differences in speed when you have different combinations in there. So
yeah. And Wi-Fi and the AP1 enterprise Wi-Fi 5 does support meshing. So you can mesh that. And like if you have like I mentioned earlier, but if you have a balanced 20x, which is Wi-Fi 5, you can mesh that with AP1 enterprises or AP1 lights. If you have a BR1, you could mesh that with Wi-Fi 6, so AX and AX light. So you'd be able to mesh, but you can also mesh Wi-Fi 6 to Wi-Fi 5. Like I said, you're just not going to have the performance. Any other questions, or I'll give people back some time. This is, I think, the first time we've ever finished early, but we'll give it a minute or so for any additional questions. But um, awesome. Well, thank you so much for reaching out. Oop. CJ, if you email me peter@westnetworks.com about the VLANs, I will lab that. I'll also create a YouTube video about it. I'll take two Peplink switches and mesh them, and then make sure the VLANs span. But I'm 99% sure that it'll work, because we've done SSIDs. But like 99% sure it'll work. But if you email me, I'll send you a link to a YouTube video where I'll do two switches, two APs, mesh them, and trunk some VLANs across it.
Cool, Peter.
And yet, okay. Well, thank you,
Thanks so
everybody,
much.
and have a great day. And thank you so much. As always, you can email Travis at peplink.com, Peter at westnetworks.com, and ask any additional questions, or if you need help, please let us know. We can always get you with a partner in your region. And little tag out there, if you like this information, you like what you're learning here, please join us, peplinktechsummit.com. Join us at the summit. Travis is going to be there helping me teach the PCE. This will be the new Peplink Certified Engineer program. So it's building off the PCA. So in November 3rd through the 6th in Orlando, Florida, it's going to be gorgeous. And we're going to have the Peplink Tech Summit in Orlando. And like I said, Travis is going to be joining me. So I'm really excited to have the two of us. And then Agent Adam and Captain Nick from New Zealand and Europe are joining us, and they're going to be teaching the PCA. So if you don't have your PCA and you want to get your PCA, you can get that. And Agent Adam and Captain Nick are going to be. So this is a globally, supported event. And then John Grote from Frontier and Tim Swayze from West Networks are teaching the sales course. And then Travis and I are going to be teaching the engineering level course. So if you like all this information, you like what we're pushing online, I highly encourage join us this November in Orlando, Florida.
Can't wait.
Thank you. Have a great day, everybody.
Thanks, folks. Goodbye.